Hey guys, it's Miss Fearing here. Welcome to Unit 6 Notes 4. Today we're going to talk about exponential decay. So yesterday we talked about exponential growth, and that's when things were increasing or getting bigger. Today we're going to talk about exponential decay, when things are decreasing or getting smaller, going down. So our equations are going to look pretty similar here. We still have y equals c times 1 minus r to the t. So the only thing that's changing here is when we are talking about decreasing or going down, this becomes a subtraction. So this subtraction tells us that we are decreasing or decaying. So yesterday it was an addition because we were adding. We had that 100%. Remember that 1 is like a 100% plus yesterday, our rate. And so today we're going to talk about that 100%, and then we're taking away a rate of change or every single time that we move or every single year. So the variables stand for the same thing. Our C is still our initial amount, the amount that we start with. Our R is still our rate of change. We want this, remember, as a fraction or a decimal, not a percent. If it's a percent, we have to change it. And then t is going to be our time. Remember, that is also can be interchanged as our x value. So we can always write that as our x as well. So let's go ahead and look at this first example here. We want to go ahead and write an equation, and we are asked to write a decay equation. So we know that we have 1 minus r instead of 1 plus r. So when we are doing this, we're going to have y equals our c value, 16, times 1 minus our rate, and our rate is already as a decimal, not a percent, so that is good. We don't have to change it. All to the x. Remember, I use the x when we're not talking about time, so that's all to the x power. So to create our table, I always use the same x values, -2, -1, 0, 1, 2, 3. And we're going to take those and we're going to plug them into our equation to get our y values. So just a reminder of how to plug this in. You're going to type 16 parenthesis 1 minus 0.45, parenthesis, and then your caret key. And then the x value that we're going to put in, we're going to put in a -2. When I go ahead and do that, I get 52.9. You're now going to take that same equation, but you're going to change this to be a -1, change the x power to be a -1. When I do that, I get 29.1. Make sure you're plugging these into your calculator and getting the same answers. We don't want to be doing it wrong the entire time. So we plug a 0 in, we get 16. Plug a 1 in, I got 8.8. 2, you should have got 4.84. And then 3, we should have got a 2.66. So now we're going to go ahead and we're going to graph these. So at -2, I'm going to be all the way up at 52.9. At -1, again, I am all the way up at 29, so somewhere way off the graph there. At 0, I'm going to be at 16. At 1, I'm going to be at 8.8, so almost to the 9. At 2, I'm going to be at 4.84, so almost to 5. At 3, I'm going to be at 2.66. So I end up getting this type of graph here. Remember, we don't ever want to cross the x-axis, so we don't want to cross that, so that's good. And we can always check to make sure if this is a decay graph, if I read this from left to right or follow it from left to right, I am decreasing, I'm going down. So that is a good sign. That means that I did something right and my graph is good. So we can go ahead and look at example number 2 here. I'm going to help you write the equation out, and then I want you to go ahead and try the table and the graph on your own. So our equation, again, we're asked to find a decay equation. So we know that we want to be a y equals a c times 1 minus r to the x value. So my c is 15. So I get 15 times 1 minus. This is a fraction, not a percent, so that's okay. We can put it in as 1/3, all to the x power. So I'm going to use that same x values, -2, -1, 0, 1, 2, 3. I'm going to show you how to put it in your calculator, and then I'm going to have you go put those values in. So we want to do 15 parenthesis 1 minus. That 1/3 is a group, so we need to tell our calculator it's a group. So we're going to do 1 divided by 3 in our calculator. close those parentheses, caret key, and then plug in the x value that we're plugging in. We're going to plug in a -2. So I want you to go ahead, pause the video, complete the y values in the graph, or in the table, and then go ahead and graph them, and then come back and check your answers and make sure that we're doing this correctly. So when I went through and graphed this is kind of the graph that I got. Make sure that you check your answers. If you got anything different, please come talk to me. More than likely, it's just plugging it into the calculator wrong, but we want to catch that mistake now before we get going on the quiz. So let's go ahead and look at number 3 here. We're going to look at some applications now for decay. So we have a fully inflated raft that loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. We want to write an equation to represent the loss of air using the general equation for decay. So we're going to do that first. So when I am looking at this, I know that I want to be in y equals c times 1 minus r to the t power. So our r, I always look at that first, my rate. I need this to be a decimal that is not a percent. So we need to divide it by 100 or move the decimal twice to the left. So if I do that, I'm going to get 0.066, and that's going to be my R value. I already have my initial where I started from. This is going to be my C. So I'm just going to plug things in. I get y equals C times 1 minus my rate as a decimal, not a percent. And since we are talking about time now, I'm going to use that t power. Part B then says estimate how much air will be lost after 7 days. So I'm going to go ahead and plug 7 in for that exponent. And then when you plug this into your calculator, make sure that you put your parentheses around that 1 minus your rate. And then don't forget to hit your caret key before you get the 7. When I do this, I got 2,790.23. So this tells me how much cubic inches I have left in my raft. So this is left in my raft after 7 days. But the question is asking how much air have we lost. So we want to go ahead and we want to take what we started with and subtract what I have left to see how much we lost. So if I do that, I get 1,709.77 cubic inches lost. So here's our next example, example number 4. During the past several years, the population of Campbell County, Kentucky, has been decreasing at an average rate of about 0.3% per year. In 2000, the population was 88,647. Write a decay equation that represents the population since 2000. Then, assuming the trend continues, estimate the population in 2013. So I have my C value here. And I know that this is going to be decreasing or decay because I see that word. That is such an important word for me. So when I see decreasing, I know I'm going to do decay equation. So I'm going to have my y equals c times 1 minus r to the t. So next thing I look at is my rate. I do have a rate, but it's as a percent, so we want to change it in a decimal, so we're going to move it over twice. So my rate is going to be 0.003. So I'm going to plug all that in. I get y equals c was 88,647 times 1 minus my rate, all to the t power because we're writing an equation that has to do with time. So I need to figure out what number I'm going to plug in to find my population in 2013. So I need to figure out how much time has gone by. Well, from 2013 to 2000, 13 years have gone by. So I'm going to now plug 13 in for that t value. 1 minus 0.003 all to the 13. When I plug that into my calculator, I get 85,251.31. Remember, we're talking about a population, so we can't have 0.3 run of a person, so we want to round that up to the nearest whole person. So I get 85,252 people. So here's our last application here. Number 5, during an economic recession, a charitable organization found that its donations dropped by 1.1% per year. Before the recession started, its donations were $390,000. Write a decay equation representing the charity's donations since the beginning of the recession. Then estimate the amount of donations 5 years after the start of the recession. So the big word I see here is decay. So I know that this is going to be a decay equation. So I want you, remember, we're going to write decay as y equals c times 1 minus r to the t. I want you to pause the video. I want you to try this one on your own and then come back to me and check your work. So when I did this, I got $369,016.74. If you did not get that answer, please come talk to me before moving on to the next example. More than likely, you forgot to turn your rate into a decimal and not a percent. But there could have been something else that went wrong, so make sure you come chat with me. Here's the last thing we're going to look at. We want to make sure that we can determine if the following exponential functions are growth or decay. So the way that we're going to do this is we're going to actually go back to that a times b to the x that we talked about a couple days ago. This equation, when we want to tell if it's growth or decay, we're looking at our b value. If our b is greater than 1, we have a growth situation. So if b is greater than 1, we have a growth situation. If b is less than 1, then we're talking about a decay situation. And that makes sense because if we were growing, we'd have 1 plus something, so the number would be bigger than 1. But if we're decaying, we do 1 minus something, which means the number would be less than 1. So this kind of makes sense if we think about it. Now, the really big thing you have to think about is which value is your b value. Your b value is the one that has the power attached to it or the exponent attached to it. So if I'm looking at the first one here, the number that has the exponent attached to it is the 7. The 7 does. So this tells me that since 7 is greater than 1, this is going to be a growth situation. That's a growth situation. Looking at the one below it then, the thing that has a power attached to it is this 2/5 right here. So when we do that, if you can't tell if 2/5 is less than 1 or greater than 1, plug it into your calculator. Do 2 divided by 5. When you do 2 divided by 5, you get a decimal, so which means it's less than 1. So this is going to be a decay situation. It's going to be a decay situation. Look at this next example here. The number that has the exponent attached to it is the 0.75. So if I go ahead and look at that, that is less than 1. So that, again, is a decay situation. Ooh. Decay. I want you to pause the video. I want you to try the last two on your own and then come back and check your answers. So here's what I got for the last two. I'm looking at the number that has the exponent attached to it. And both of those, the 4 and the 5, end up being numbers greater than 1. So both of these are going to be growth situations. So your next step then is going to be moving forward onto the practice for 6.4. Remember, the biggest deal that you're trying to think about is, am I talking about a growth or a decay situation? Look for those words like increasing or decreasing. That'll really help you determine which equation you're writing.